see you all, and as I'm here this time, and my colleague wasn't able to participate, so I'm here alone. But let's see if I can cover this topic. My name is Jānis. I'm a Devops practice lead here at Emergent, and let's talk today about how we can enhance secret management. And let's start with some meme about, let's read it. Maybe some of you can recognize this picture, maybe you can relate to it, and it could be, we could get some stress from this situation. And today's talk, let's see why it happens and what we can do about it. So, in general, it's about infrastructure as code, configuration as code, secret handling options, and how to clean up things. So, we committed plain secrets in source control, maybe pushed into GitHub. So what? So if it's public repository, it depends on what you put there, but probably you know there could be some resource access keys, usernames, passwords, access to some public resources that your company owns. So there's a lot of things to put publicly into the GitHub maybe. So it could, of course, lead to data breach, maybe financial losses, because if the resources are discovered as free for use, then everybody maybe could use it and mine some Bitcoin maybe on some resource, or check out some data from your S3 bucket. Also, it could lead to some security risks for infrastructure, and probably that's not the big news for you. But regarding private repository, we may think that it's kind of more secure, and probably it is, not so bad, but I would say I saw situations or companies where we have lots of employees and lot of Git repositories, and company have policy that everybody can access every repository. So maybe not right or change, but you can just go and see what other teams do. So in general, it's kind of also public and could lead to same risks. Here at the bottom is kind of small example. Let's think about maybe somebody who is kind of focused on security. Security questions may imagine what could lead, where situation could lead if there is some Active Directory bind user and credentials stored in the Git repository. Maybe it's fine, but maybe it will have some consequences later. So, and why do we need those kind of sensitive information or credentials or usernames, passwords, API keys, and all that stuff into Git repositories? In general, so as every modern companies, we would like to use modern approach or normal approach, or to use or provision infrastructure as a code, use infrastructure as a code principle, configuration as code principle, and in general, how it works is that there is some version control system where every property, or there is stored a lot of information about how your infrastructure must look like, and then there is some automation, some process that reads the repository and then do the changes in your infrastructure or in your deployments. So in general, everything is in the source control. And of course there is... Can you please stop the sharing here? Okay, I'll try. Sorry. So everything is in source control, and we are getting a lot of benefits of that because we like to have everything in a single source of truth. In this case, this is a Git repository. let's say our version control system, we could get automated deployments, immutable infrastructure, automated multi-tenant environments, disposable environments, and this of course can save us a lot of money and time. And also, if you are kind of write our code to deploy everything automatically, we are kind of one big step closer to disaster recovery plan to be implemented. We just need to add some pieces from backup, and then we are fine to go. And if we can read our code, then we have also, then we already have documentation also. And there is of course a lot of tools that can provide us those benefits, and those tools are focused on maybe little different areas, like starting from infrastructure templating, managing infrastructure, installing applications, configuring them, and then deploy configuration changes and some post-install actions. And we will not touch every tool in here, but let's take some examples from some of those tools and how they look like. So we are starting to write or describe our infrastructure in the code blocks, and depending how it's what tool we use. Let's say if we use Ansible, then it's you can show, maybe not from the far side, how it would look like for the Ansible, and then there is small Terraform example also. But in general, what we would like to do first, just put everything in a plain text here, just to start things. And maybe that's the case when some small project starts, everything is very simple, and then maybe it's not fixed later, and some best practices follow, but that's the way how it could start, and or playbooks or code will work, but everything will be in plain text. And if you think about GitOps, let's say for using in Kubernetes, then again, everything we like to deploy on our Kubernetes cluster is stored in a code repository, and that could be push or pull approach when we trigger or code changes to Kubernetes cluster, or maybe Kubernetes cluster will kind of pull the changes from the repository. But then again, there is some challenges, because usually there is some kind of secrets involved in deployments. Maybe we need some fixed password to be stored and deployed in the Kubernetes. Maybe there is some certificate, some API key or whatever. And usually it's stored in the secret resource, and if we put that secret in plain text in our Git repository, then there it is. And we need to solve somehow that situation. And also we need to keep in mind that when we are running our tools, that usually, not usually, but when we're running our tools, there may be situations that our tools somehow leak the sensitive information. And what we must learn from that we need to know our tools. We need to how to use our tools, because usually those situations also can be handled and fixed. Let's say if we talk about Terraform, then we can see some sensitive information maybe in plan apply stages. If that information is not secured. Regarding Ansible, if we do not put no log policy, then we can expect a lot of sensitive information in our logs, and so on. So the thing we must take into account when tools work, or we are running our tools, they may expose also some information. Even we kind of have taken care about our secrets in the Git repository. So, as we see, the version control and secrets environment variables are very suitable and convenient for infrastructure as code, configuration as code. We can see what is current values in our infrastructure, what was values in some previous deployments, some history changes. We can review, we can build the processes where we can change things and ask somebody to approve those changes. So there is a lot of good stuff we can do about it. But we need to think about how to hide this sensitive information that is required for our infrastructure, and it can be in our Git repository. So there could be some options how to handle that, and one of those options could be store those secrets somewhere outside the Git repository and just use some references or placeholders in your code, and then the tool will know how to get the secret from the outside repository or outside source. Or we can maybe encrypt our secrets and then safely store it into Git repository. And yeah, as I mentioned, learn the best practices for your tool usage to not leak those secrets when you are running your tools. And now I will take a little water, because I think this is a very useful schema. This schema really helps me for work and solves some challenges that we may experience during our work, and a little bit explain. So in general, if we think about our situation, then there is our kind of maybe source control, and we're working inside our company, and maybe everything nicely puts into our Git repository, and we are deploying everything as we like, and we don't need any changes. But let's say in our situation, when we need to build the same infrastructure, which is kind of same or built on same principles that is delivered to client, then we need the same scenarios and code that builds infrastructure to run into our infrastructure, and we need to synchronize that code to a client repository, so the client may run the same code and get the same result as we prepared. And how to solve that? And I suggest that we need to completely remove environment descriptions out of source code repositories and place those in, let's say, different repository, and we call it like inventory repository. And in our source code repository, we have everything that we would need to build new environments, starting from kind of inventory for those environments, because let's say inventory contains a lot of variables which must be filled with different values for each environment. And what if we add new environment variable in our environments? We need to repopulate this to our all environments, and also we need to deliver that new environment variable to our client, and to be sure that client also will repopulate their inventories with new variable, fill the values, and new deployments will work correctly. So therefore, we add the templates of those inventories for environment definitions, and corresponding code to verify that everything is updated, everything is kind of completed, filled with the values, and it can be run safely to environments. And there is kind of graphical representation with the colors, like those would be values for environment variables, and we see the code is the same that runs in our infrastructure. Values are from our inventory. We synchronize code to client side. Client runs our code, generates templates for environments he needs. He fills the values and deploys the infrastructure in their environments. So that's kind of makes us sure that we are running the same infrastructure, or client is running the infrastructure we built, and we prepared for them. So in the previous slide, we moved out all of that inventory, and we could do, like as I said, two things. We could use some external vault to store our secrets, and maybe some of popular vaults like HashiCorp vault or some of the cloud providers vaults. And what we use, we use secret providers, and our code is referencing to those providers, and providers know where we can get those secrets. Kind of values of those secrets are outside of our code repository. We have only reference. And second approach would be, not everybody maybe could have kind of nice shiny HashiCorp vault to use, but need to move quickly. So another option would be encrypt that sensitive information that must be stored in the Git repository. And if you're talking about Ansible, there is available Ansible Vault, which can encrypt files or lines, and then the content looks like this. Another popular is Mozilla SOPs that can work with various KMS, and then like Kubernetes secret would look like his, that we can structure, but the sensitive data is encrypted. And regarding that challenge for GitOps approach, where we need to store Git's secrets in Git repositories, we could, as an option, we could use, let's say, sealed secrets, where we can deploy controller on the Kubernetes side. Controller owns public and private keys, and the public key is meant for encryption. We encrypt that secret, store in a Git repository, and when Kubernetes cluster pulls that information, it decrypts with a private key, and you're lucky. So let's rewind that situation when we had on the second slide, when we realized that we put something into public repository. So what we can do about that situation? Of course, one of the good approaches is rotate the secrets, and then we are kind of covered for the moment, but maybe we can try to remove that secret. Anyways, when we're done, let's move it to external vault or encrypt. So there is some example of repository. There is some scripts, some programming, running, and then there is prod secrets and test secrets. And we can see that there is kind of content show that there is no secrets here. But luckily we have some tooling that is able to dig into Git history and check, maybe somebody make a mistake and add some secrets into previous versions of Git. And some of those are truffle hug and Git secrets, and they have kind of lot of functionality that we will not cover here. But in general, let's say we run truffle hug on that repository, and it shows, there is some Jānis Pērkons who added some suspicious string, looks like a secret, into this file. And if we see then deeper in Git history, then yes, Jānis realized his mistake and made a commit where he removes the secret that he put before into the repository. So kind of all good, but no. How to clean up? Luckily, GitHub docs have a nice documentation about how we can clean, remove sensitive data from our repositories, and basically there is two tools suggested, Git filter repo and BFG, and one thing you may, so we can use both of those tools. Some of those tools have some advantages, maybe one is better in one area than other in other, but let's say what we can do with the git filter repo. So in general, we know in this example where we stored our secrets, and we would like to remove this file from the git history. And of course it would be kind of more convenient just to remove maybe one string, which is kind of that secret, but unfortunately we cannot remove from history just one line of the code. So in this case we use this git filter repo. We are specifying path to our secrets file, and we use invert path parameter to say that we will remove this file and run the command. So what we are getting, if we got before this commit history, where we had the remove secrets commit, then now the commits are kind of less, and there is no more this file in the history. So what we can do next, if we are lucky, we are kind of adding bat or remotes, because this tool removes remotes, and pushing back to, let's say, GitHub. And we see in the GitHub history, yes, we have 3 commits, only 3 commits, no more secrets. Lucky us. But maybe we are not so lucky if someone already has our kind of copy of our source repository, and he didn't not notice it that we updated our repository or did our changes, and he decides just, oh, okay, I will push back, and I have a right to push back with the force option to the same repository. There's something happened, don't care. So in general, we are kind of getting back our content in this case. So we must think about how to handle those situations and how to plan those actions. So maybe there is, if that's possible, I would say the best option would be consider the secrets that are optimized and rotated. But you must know, if you decide to clean up the repository with git filter repo, then it will change your commit hashes, and it may mess up with some integrated tools. Maybe you have links to those commits somewhere in some ticketing system, some other integrations, like I would say Azure boards will fail after that, because also there's links to commits or that stuff. So this must be kind of planned, and you must think about consequences. So to not get into that trouble, let's think about what guardrails we can use. And one good thing would be integrated git pre-commit hooks that could prevent even committing such information to your Git repository. And then, of course, if you badly need those secrets, use git ignore. You can have it locally. You can build the pipelines that use those tools that goes to the repository, checks if you committed something and need to rotate some secrets. And as I mentioned, encryption, centralized secret management. Think about isolation. Let's say you have some jump host where you run those tools, do not share access, keep everything safe. There's 3 buckets, let's say, for Terraform state files with limited access, and also rotation. Regarding other side, that there is a Devops who is trying to make things work in the infrastructure as code style, but also there is developers who write the code and build applications. And there is that will factor up site which describes what would be the best practices for building microservices or apps. And regarding those secrets, there's a question how to provide those values to application, and this site suggests that it must be done. It can be done by the environment variables, and that's a good approach. but I think there is a place for discussion, because if you are thinking about deploying some application in Kubernetes, you can use like mounted volumes with configuration files. We can use environment variables, and there could be some situations that is one option is better than other, because what if application exposes environment variables? If we put everything there, like other stuff also that we would like, that's not application related, then application may leak some additional stuff. If that's kind of file-based or configuration file-based access, then the process who is running on that configuration file probably can access, but maybe some other processes from that application or from that environment cannot access that configuration file. So we can think about our situations and which approach would be better. Yeah, and of course not everybody must need to know everything, but my comment about the capabilities would be that it's good that we are proficient with source control management. We can know how to do things and do not make some not nice mistakes. If we know how to handle build pipelines, how to automate things, if you understand those principles like infrastructure as code, if we build applications, we may need to look into logs and metrics and know how our application works, and is there any danger about our application or what we are doing, and also understanding other best practices. And just for the final closure, let's say I asked some days ago already, I asked ChatGPT to finish my joke, and I asked, can you complete this? Pod, service and secret walks into bar, and ChatGPT says to me, the bartender says, sorry, we don't serve you kind here. The pod replies, that's alright, we will just network somewhere else and keep our secrets to ourselves. Thanks. I don't know if there's part for questions. Yes, please.
You mentioned that we can rewrite history with different tools, BFG and the new one, which is available on Git. But what's the point of doing this in case on remote, on the host? I mean, the hashes will still remain because you cannot collect everything from there. Yes.
So, what to do with some leftovers, you think? Yeah? So there was a note that if you do this locally, it may clean things up locally. If you push it to GitHub, it may also push everything to GitHub, but still you may need to contact the GitHub support to clean up some, I don't know, merge request stuff, caches, all that stuff. So you may need additional help. Also, if somebody else already cloned the repository, as you see, there could be a lot of trouble. But I would say when it works, like from my experience, when there is kind of big movements in, I don't know, in team, in setups, so like moving from one provider to other and moving repositories and then realizing, ouch, we have a lot of secrets in those repositories, let's start in a new place with a fresh start, so and don't take that luggage with us, so we can take out our code, clean it up, and put it in a new place and start new shiny life.
You mentioned to not include descriptions of the environment files. So what did you mean by that into the repository, like not including n file into Git or what? Could you elaborate?
No, my idea was that if that's possible, we could separate the code that builds infrastructure and the variables that is required for building that infrastructure. I know there is kind of default structure for repository that prod here, test here, and so on. But as I say, always a question, do we have all variables in those environments specified? When we add new variable, how we populate all environments? Do we have kind of nice reliable processes how to be sure that each environment will have kind of the new variable? And if we deliver that the code to client, we don't like to be delivered to a description of our environments. So that's why in our example, we create additional Git repository where everything is stored, and we create on a join host symlink to that repository, including in the structure, and then just by running those scenarios, it kind of takes everything from the second repository.
Okay, yeah. Thanks.
You mentioned that the approach when you don't have these fancy secret managers, when you store encrypted password, so you have like a private key and public key on the Kubernetes. But how can you store these keys to get it to the Kubernetes?
So okay.
Where do you store them to get them there? Like, what's the approach?
So you have the private key in Kubernetes secret, nice. You need to kind of make a backup of that key.
Yeah, but where do you store it? Like on a flash drive or?
Oh, a lot of options.
Yeah, but what would be your suggestions? If you don't have the secret managers and all that stuff, like what would you
pass and go home.
Just the try
KeePass? As I said, there's a lot of options. There is no good best answer. No, okay, it's kind of, if it's stored locally on your kind of on some of your storage, then okay, it's a good question, and there is no kind of best answer for that. Where to kind of where to store or make that additional copy of very precious data of you.
Okay, fair enough.
Question. You have advised good tool how to parse GitHub repository, and I have a question. Probably you can advise on a tool if secrets are already exposed in logs or artifacts. So is it possible to parse logs to retrieve if secrets are already exposed? Make self-audit.
Maybe I didn't understand your question correctly, but like the situation is we use the tool to discover that the secrets is in the Git repository.
No,
and
if already bad things happened, okay. Someone exposed it, did like echo environment variables in artifacts, and we have already in our logs and artifacts some. So I have assumptions that probably someone from my company exposed environment variables in logs. Is there the tool which can parse my logs?
Yeah, I think there is a lot of tools that can parse logs. The question is those logs stored? Can they be kind of searched?
GitHub logs, GitLab.
No, I don't. I cannot recognize kind of such a GitHub logs. Maybe we need to kind of clarify the question a bit later, or if I may help. So in general, if something runs and produces logs, and logs are somewhere stored, then we can parse those logs and analyze what's happened. But maybe, okay, let's say application exposes environment variables in some way, what sometimes happens. So we know that making some bad malicious request to the application endpoint, bad things will happen, or
okay.
something will be exposed. So we'll
yes.
search for those indicators. If those happened in our logs, we can identify them.
Okay, thank you.
Git leaks and truffle hawk.
Git leaks?
Secrets can analyze logs as well.
Git leaks.
Yeah, Travelhog also have a functionality to check if those secrets are actual. Maybe you have some secrets in history that already is rotated. So if there is a AWS key, the tool can check if that key is valid still or not valid.
Okay, thanks. But my question was like very practical. Like I have exposed in CI/CD in artifacts. There are like something that looks like.
Travelhog can scan for
Ah,
artifacts
okay.
and
It
for file systems.
Okay, so I've got the answer. Thank you.
So, okay,
Thank you.
maybe understood. So I'm looking for possibility maybe to scan Docker images and to see if something is packed inside those images, maybe can hard-code it, maybe no. But,
I already got the answer.
okay,
Thank you.
okay, sorry. So, if no more questions, thanks.
Thank you.